Why you still forget JavaScript? Real reason? Based on everything you've studied, React, Node, systems, books, etc., your issue is not intelligence or effort. It's this: you've been learning APIs and patterns, not execution models. Example, you might know r.map, parameter x, arrow function x times 2, but forget it later because it's just a surface pattern, not something grounded in how program run. What your brain actually remembers long term, from your reading style, deep books like Operating Systems 3 Easy Pieces and Inside the Machine, you retain things when you understand structure, to cause, to mechanism. Second, what crafting interpreters really give you. From crafting interpreters, it teaches you how code actually executes, code to AST to evaluation to result, why things behave the way they do, why variables exist, why scope works, why errors happens, why control flow skips code. See the mental machine. Instead of memorizing JS, you'll think what is being evaluated, what is stored, what is executed. But here's the critical correction: wrong expectation. If I understand interpreters, I'll remember JavaScript syntax. Correct expectation: if I understand interpreters, I won't need to memorize JavaScript because by heart you'll be able to know what runtime it will execute. Fourth, why your current approach fails precisely. You've been learning like syntax to features to frameworks, but your brain, based on your reading habits, prefers model to mechanism, then derives syntax. So you start with the bottom before you get into those higher or abstracted level. Fifth, what will happen if you finish crafting interpreters? You will start seeing JS like this. Instead of if parameter A and B, so and symbol B, and then open and close semi-curly bracket, you'll think evaluate A, if false stop, else evaluate B. Instead of obj.prop, you'll think look up property in object structure, heap. 6. Why this fix is forgetting? Because now you are remembering rules, not syntax. Syntax is shallow memory. Rules are deep memory. 7. One subtle mistake you're making. You said to truly understand programming language and know how to code. These are different. Skill, language theory, what it is, how languages work. Skill, coding fluency, what it is, fast recall, plus patterns. Crafting interpreters gives deep understanding, not automatic fluency. 8. What you're actually missing, precise diagnosis. First, you don't practice reconstruction. You read complex books, but you don't rebuild concepts from scratch. Second, you rely on recognition, not recall. You recognize code when you see it, but you can't produce it. Third, you don't connect JS to execution. You treat JS as API surface instead of execution model. 9. The correct strategy for you based on your background. Step 1. Finish crafting interpreters. Focus on evaluation, environment, specifically for variables. Then control flow. Step 2. Map everything to JavaScript. Example, locks environment in JavaScript. That's scope. In locks interpreter. In JavaScript, that's ignition. Locks AST, JavaScript, that's internal representation, which is the IR or the ignition as well. Step 3, reconstruct JS manually. Instead of how do I use map, ask how would I implement map. Then, what will change in your thinking? Before I forget syntax, after I I know what needs to happen, I can create it. Final insight, this is the real answer. You don't remember JavaScript because you learned it as a tool. You will remember it when you understand it as a machine. And crafting interpreters is exactly building the machine yourself. Age 27 is actually an advantage, not neutral. You're not starting from zero, you already have real systems experience, React Node, APIs, mental models, hardware understanding, system thinking. Why that matters? A beginner reading crafting interpreters sees tokens to AST to interpreter. You can see language to runtime to memory to execution to CPU. That's a completely different level. Second, what doing the hard work now actually gives you, not syntax memory, not shortcuts, it gives you transferable mental models. Example, this is the real payoff. After learning interpreters, concept variable, you'll understand in any language memory bindings. Concept functions, you'll understand in any language stack frames. Concept closures, you'll understand in any language environment capture. Concept async, you'll understand in any language scheduling plus continuation. Concept errors, you'll understand in any language control flow interruption. Meaning, when you learn a new language, you don't start from zero, you map it to what you already understand. Third important correction, so you don't expect the wrong result. It will not make you instantly fluent in JavaScript. Remove the need to practice coding. Replace building projects. It will make bugs easier to reason about. Make new languages feel familiar. Make weird behavior predictable. Why this matters at your stage? At 27, your bottleneck is not learning syntax, it is building deep mental models. Without this, you'll keep experiencing forgetting syntax, confusion across frameworks, shallow understanding. With this, you'll start thinking like, what is this code at runtime instead of what is the syntax again? How it makes future learning easier, real mechanism. When you learn a new language later, without interpreter knowledge, new syntax to memorize, to forget, then repeat. With interpreter knowledge, new syntax, map to evaluation model, understand, retain. Example, learning Go, Rust, or Java. Instead of what is the syntax, you think, oh, this is just a different way to represent scope slash control flow slash memory. The real long-term effect, after finishing crafter interpreters, you start seeing all language as variations of the same machine. That's when React stops feeling special, Node stops feeling complex, new frameworks feel predictable. 7. One subtle warning important for you, you read deep books, that's good, but it creates a risk. Staying in theory, not reinforcing with code. Rule for you, for every concept in crafting interpreters, implement something small in JavaScript. Honest answer to your question, will it make it easier in the future? Yes, if you do this. Understand evaluation deeply. Connect it to real code, JS, React, Node. Practice reconstructing concepts. No, if you only read it, then it becomes another concept you kind of understand but don't apply. Final, at your level, the highest leverage is not learning much more tools. It's understanding what all tools are built from. So all the tools are built from the interpreters again. And the way we evaluate the AST is an interpreter, applying a function and then converting it to a node. Another thing is that our code or the interpreter code in the programming language, the those combine makes the code representation that will be fetched by the OS to a CPU. And a CPU, remember, is 100 times faster than memory. That's why it uses cache. So those cache, the way it use it is that whenever it carves something out of that memory, it also do it in its spatial location bytes. so that because those bytes are more likely to be related to each other. So therefore, it gets that and then cache it. And when the program in the memory requires that again, then the CPU can easily execute those cache instead of 100 times slower. So that's another thing that you would understand uh, with regards to, for example, in React, right? We use V8 to run that, but how does V8 actually works under hood? It uses ignition. So that ignition is your interpreter, the one that's applying function to that AST that that JavaScript created, and then enforcing it to a value. So the turbofan is the one compiling that code and then returning it to machine code that an OS can fetch to the CPU. And another thing is that the JavaScript use a just-in-time compiler, meaning whenever you use the code, that's the only time it compiles it. So it's optimized for that. That's why it also has that hat codes, where those hottest codes being run by your program are being optimized, and therefore, if it is compiled, it is being put on the cache of the CPU, so that the program, when the program requests it, it can easily execute by the CPU. First, it's lexical scope, the environment class in logs. Not exactly. The environment class is the runtime representation of lexical scope. The distinction, this is important. Concept, lexical scope, what it is, a rule from the language grammar. Environment, logs, a data structure that implements that rule. So the environment are the runtime representation or the data structure where the program runs. Just like with data structure we've mentioned earlier that is being fetched to a CPU for hat codes. So those code representation is the data structure. Those are the same environments we're talking here that implements the rule of lexical scope. And again, scope is related to the closure or the environment in a programming language or in any programming language. In crafting interpreters, lexical scope means a variable is resolved based on where it is written in the source code. Then, so that's another thing with environment, is that it is highly related to variable because a variable is resolved based on where it is written in the source code. So again, that's the keyword, where it is written. The environment class is how logs enforces that. So environment colon values colon map. So the values member has a value map which has name to value mapping. Then next member is enclosing with a value pointer to outer environment. So the environment class or the data structure are the one enforcing that resolution of a variable. So that code representation of runtime are the one enforcing the programming language variable based on where resolving it based on where it is written in the code. So when you do var a equals to 1, then inside var b is equals to and then open and close semi-curly bracket, inside that open and close semi-curly bracket var b equals to 2 semicolon. So at runtime we have global environment a member with the parameter with the value 1, and then inner environment b with the value 2. Second, is this the same as JavaScript code scope? Yes, conceptually the same. In JavaScript, function outer, then open semi-curly bracket, let x equals 10 semicolon, next line function inner, then semi-curly open semi-curly bracket again, console.log parameter x, then return inner semicolon, then closing. So under the hood, same idea as locks, JavaScript creates something like environment outer x equals to 10. So this is where the interpreter actually run the code. So it has the outer environment and an inner environment that helps the variable to be resolved to where it is written in the code. Third, where closures come in, a closure a closure equals to function plus its captured environment. So a closure is kind of different with scope in that scope has the function, variables, etc. that allows it to resolve those variables depending on a global or inner scope of that variable, depending if it's inside the function or it's in the outside of the function. But for closure, a closure is equals to function plus its captured environment, not the variable itself. So in locks, when a function is created, function resembles the environment where it was defined. So the function remembers the environment where it was defined, kind of like the variable resolved to wherever it is written in the source code. Now the function remember, so that's the keyword, remember the environment in the source code where it was defined. So in JavaScript, same thing, const fn equals to outer function semicolon, then fn calling fn function still sees the x. Why? Because fn carries a reference to the environment where x exists.